This is 2.5b, implicit differentiation. Let's make sure that we can take derivatives with respect to the correct things. All right, so this first one, we got to determine the slope. Determine the slope of the graph. 3 times the quantity x squared plus y squared squared is equal to 100 xy at the point 3, 1. All right, so let's take a derivative because that's what's finding a slope. So what comes out first? The 2. The 2 messes with the 3 to become 6. And then I have x squared plus y squared to the power of 1. But because of the chain rule, what do I need to take a derivative of? The inside. So what's the derivative of x squared? 2x plus the derivative of y squared, which is 2y dy dx, because implicitly it pops out. And then is equal to, now what is this 100xy thing? This is involving a what rule? A product rule. So what's the derivative of the first? 100. And then times the second, which is y. And then plus the derivative of the second, which is dy dx. And then times the first of 100x. So right there is the calculus part. That's it. The rest is going to be algebra. Now, before on our board point, we actually solve for dy dx before substituting in. And that is a good and sufficient way to do it. Or we can actually just go and substitute in right now. Sometimes it's easier just to work with numbers. All right. So which one would you rather? Would you like to solve for dy dx or just substitute in?
Let's do the substitute in.
All right, let's do it. All right, so we're going to substitute in. So 3 squared is 9. 9 plus 1 squared, which is 10. So 10 times 6 is 60. So now I have 60 times. I substitute in 3 there. I get 6 plus 2 dy dx is equal to 100 and then plus 300 dy dx. All right, and so now we need to solve for dy dx. However, what do we have to do with this 60 still? Distribute them in. All right, and so now we'd end up with 360 plus 120 dy dx is equal to 100 plus 300 dy dx. Now, I personally would move my dy dx's over to the right to keep them positive. So how many dy dx's do I have on the right now? 180 dy dx is equal to, I'd move my constants over to the left, so I'd get what? 260. So now this is where notation is extremely important. I took a dy dx at the point what? 3, 1. And so what was my dy dx or my slope at 3, 1? 260 over 180. Now, technically we could keep it like that, or if you wanted to simplify it all the way, it would be 13/9. All right, so this one, we are given our equation x squared plus y squared equals 25, and we're going to find the second derivative with respect to x. And we're going to evaluate the first and the second derivative at -3, 4. So if I need to find the second derivative, first I need to find the what? The first derivative. So Gail, how do I take a derivative of this? What do we get? 2x plus 2y dy dx is equal to 0. So we need to solve for dy dx. So what do? We subtract 2x and then divide by 2y. So dy dx is equal to what? Negative 2x over 2y, which simplifies to negative x over y. All right. So now, let's just go ahead and evaluate at this point. So we're going to have dy dx at -3, 4. And so when we substitute -3, 4 in, what do we get? 3/4. Now, what did we just learn? We just found the what? The first derivative at that point is 3/4. But what does that mean?
That means it's the slope.
The slope at that point is what? 3/4. That's what we just found. All right, so now we're going to find our second derivative. So we have to find our second derivative. So we have d2y over dx squared. So we find our second derivative using the first derivative. So now I have to take the derivative of this one. And so what rule are we going to use?
Quotient?
The quotient rule. So let's go. So how do we do the quotient rule? The derivative of the top. So what's the derivative of the top? -1 times the bottom, which is y. And then minus the derivative of the bottom. So what is the derivative of the bottom? dy dx. There it is. And then times the top. All over the bottom squared. All right? And so what's vitally important that we need to see here is that dy dx is equal to -x over y. Well, what do we have in our second derivative? dy dx. So guess what? We take this and we do what? We substitute it in right there. All right? And so now we'd end up with -y and then minus -x over y times -x all over y squared. So we now have what? -y, and then we have a negative, which is a what? A negative. And so then we have x times x, which is x squared over y all over y squared. So I have this complex fraction. I like to call them fractions. So we should not have fractions, and so we need to manipulate it a little bit. So essentially we're multiplying by 1, but really we're just multiplying by this denominator. So this denominator is what? Y. And so now we're going to multiply by y over y. And so now when we multiply by y over y, we end up with y squared minus x squared. Where'd my negative go? I just missed him. He should be negative. All right, and then all over y cubed. And so that is what our second derivative is. Derivative, now we're going to evaluate it at that same point. So we're going to evaluate d2y over dx squared, and then we have a bar, and then we get -3/4. So let's substitute in. So what is my y squared? -16, and then minus, what's my x squared? 9 over y cubed, which is 64.
I never knew
All right.
Sorry.
You're good. All right. And so then what do we get? -25 over 64. So for this relation, we have the square root of x plus y equals 3x. We're going to find the value of x this time. We're going to find the value of x. And we're given that dy dx is equal to 17 when y is equal to 8. So it says we have dy dx. So again, what are we trying to do? Take a what? Derivative. So let's take a derivative. So what's the derivative of square root x plus y? What comes out front? A 1/2 comes out front. And then I have x plus y to the power of -1/2. But by the chain rule, we need to take the derivative of x plus y. So what is the derivative of x? 1 plus, what's the derivative of y? dy dx. Beautiful. And then is equal to, what's the derivative of 3x? 3. And so now before I keep going on this, I kind of want to simplify this up a little bit. Who gets to stay on top? The 1 plus dy dx stays on top. And then 2 goes to the basement, as well as this power to the -1/2 is really a square root x plus y. And so now that's equal to 3. So from there, we need to solve for x in this case and just substitute in everything else that we know. And so we're going to substitute in 17 for dy dx. So 1 plus 17 is 18 over 2 times the square root of x plus, what's my y? 8, good, is equal to 3. All right. And so now we just have to do a little bit of math. I personally would look at it from right there. But we can just do some math. And so 18 divided by 2 is how much? 9. And so then we have like a 9 up there. And what do I want to do with this square root thing? I want to multiply them over. And then we're going to divide by what? Okay, so I got 3 square root x plus 8. And so now we're going to divide by 3. And so now I get 3 equals the square root x plus 8. And then what do? We square it. And so then we get x equals what? 1. All right, so on this one, I have the quantity 3x minus y squared. However, I'm going to take a derivative with respect to x, and then I'm going to take a derivative with respect to t. All right, again, t is not my favorite variable. However, it's used all the time. All right. First one, we're going to take a derivative with respect to x. So let's take a derivative with respect to x. So what's the derivative of 3x with respect to x? Just 3. And then minus, what's the derivative of y squared with respect to x? 2y dy dx pops out. So that's when we took it with respect to x. Now I'm taking it with respect to t. So do either one of the variables match now? No. How rude. So disrespectful. All right. And so now when I take a derivative of 3, what's the derivative, 3x, what's the derivative of 3x? 3, but then what pops out? Dx dt. Beautiful. Minus, now the derivative of y squared is really what? 2y dy dt.
So the circle centered at the origin with the radius 4 and equation x squared plus y squared equals 16. Find dx over dt at the first quadrant point where x equals 2 if dy over dt equals -3 at that instant.
All right, beautiful. So these are dx dt's and dy dt's. So how did we get these? They took a derivative of this with respect to what? T. All right. And so let's take a derivative with respect to t and see where we go. So let's take a derivative. What's the derivative of x squared? 2x dx dt. And so then plus, what's the derivative of y squared? 2y dy dt is equal to 0. Very good. All right. And so now let's substitute in what we know. So we can substitute in an x. So 2 times 2 is 4. Dx dt is what we're solving for, so that goes there. And then I have 2 times y. Well, do I have a y? I don't. Can I solve for a y? Yes. How do I do it? I take this and do what? Substitute it into my original. So 2 squared is what? 4. So now I have 4 plus y squared is equal to 16. And so now how do I solve for y? I subtract 4, then what? I square root it. So technically I get y equals plus or minus square root of 12. However, which one do I want? I want the positive because we're in the first quadrant. Exactly. All right. So if that were in the fourth quadrant, then I would actually want what? Negative square root 12. All right. So now I can substitute in my y, which is square root 12, and then my dy dt, which is negative 3. And so now we just need to do a little bit of math, move some things over. And so now I have 2 times negative 3, which is negative 6. So I'm going to move over that guy. And so now I have 6 square root 12. And then what do I want to do? Divide by 4. So there's my dx dt. However, you won't find your answer like that, so we have to do a little bit more. So who's perfect in square root 12? 4. And so who gets to come out to play? 2. So the 2 messes with the 6 to become what? 12. And then the 12 is divided by 4 to become 3. And then who's left inside? Square root 3. And so dx dt is equal to 3 square root 3. So we have an implicit circuit for homework.